Everyone, my name is Usama and my registration number is 20T90. Today our video that is related to Canny edge detection. Canny edge detection is widely used image processing technique for finding the boundaries of the object within image. It is a multi-stage algorithm designed to achieve three main objectives. Uh, that's all there are the three main objectives: good deduction, good localizations, and minimal response. What is a good deduction? Good deduction actually detect all the true edges in the image without missing any. And good localization edges should be located accurately at the center of the actual edge. And minimal response, only one edge should be detected for each actual edge, even if the edge is blurred. Then data Canny edge detection algorithm consists of the few steps, which is noise reduction, gradients computations, non-maximum super, supervision, and thresholding. So we discuss it one by one. Uh, if you noise detection, this image is first smooth with the Gaussian filter used to remove the noise. This is important because noise can lead to false edges being deducted. So our first step is to remove the noise because it is a very important to deduct the edges. Else, algo can't deduct the edges if we can't remove the noise. Then second step is gradient. Gradient magnitude or traction are calculated for each pixel in the image. This information is used to identify the edges where the gradient magnitude is high. And then third one in non-max, this gradient magnitude is checked for each pixel in the directions of the gradient. If the gradient magnitude of the pixels is not maximum in the direction, it is supposed to thin the edge. And the last one is thresholding. We apply the holding to further refine the edges. Pixels with a gradient magnitude above the high threshold are considered strong edges and are marked as edges. Pixels with a strong gradient magnitude below the low threshold are discarded. Uh, then the advantage of the Canny edge detection, mm, it's a high detection rate, good localization, and minimal response. High deduction is a Canny edge detect is able to detect a wide range of edges, including both thin or thick edges. Good localizations, Canny edge detect is able to accurately locate the edges of objects. And then the minimal response, Canny edge detection, wide deduction multiple edges for a single actual edge. However, Canny edge detection has some limitations. Uh, there is some limitation of the Canny edge detection is a computational cost, sensitivity to noise. Canny edge detection is relatively complex algorithm and it is a computationally expensive, especially for a large image, and it is a sensitivity to noise. So, while the Gaussian filter help to remove the noise, but if the Gaussian can't help it, and then especially when dealing with low contrast image, and then I also design a MATLAB code so it works. Then move to our MATLAB screen. Yes, this is a MATLAB code for the any Canny edge deduction, in which uh, I make a functions for the thresholding and non-max supermax. This is a function of the yes. First we what's the threshold? Threshold is to deduct avoid the deduction multiple edges and many two thresholds are used in further refine the image pixel with the gradient magnitude above the are considered strong edge and as not. And this is a function of the thresholding and we make uh, non-max subdivisions functions in the separate script. And this is the main code of the Canny deduction in which first we standardize the derivation of the Gaussian filter because we first apply the Gaussian to smooth the image and then I give the path of my image then convert the grayscale with the image in the colored then smooth the image then display the result of the image then we gradient calculations after that, they call the gradient magnitude, and here we call the non-max functions, and then display that, and then we edge tracking by the hysteresis. Then this is basically apply the threshold. We adjust the threshold values from 0.2 to 0.1 or the required. Then again we call this threshold function and display the final results. So if run this code, first this is our original image and after the smooth Gaussian filter apply it will be like this. Then second step, this is the first step. In second step, after the smooth image we apply the gradient computational. You know about gradient computation, calculate the each pixel in the image. This information is used, each pixel of we calculate the gradient magnitude of the each pixel of the image which is useful to identify the edges. This is the second step of the Canny edge reduction, and then third after the gradient magnitude, the third step is the check for each pixel in the direction of the gradient. If the gradient magnitude of the pixel is not maximum in the direction, it is supposed to thin the edge, and we see it. And then after the applying the threshold, it will be like that. You see that this is our edge deduction, Canny edge deduction of the image after applying the four processes. And this is almost uh, or about related to the Canny edge deduction of the digital image processing. Thank you.